Hi, y'all. So, I'm very qualified to answer this question. What is plasma? So, let's talk about that. Aside from the fourth state of matter, do you remember your second grade science class? At least, 2 decades ago, my advisor was very excited. He brought me his daughter's second grade science class textbook. And right there, funny, it opens with, what is science? Science is what scientists do. And how do scientists do science? Well, they use scientific method. Kind of a circular definition there. Anyway, that's the only time in your formal education that the textbook tells you that there are, in fact, what I remember from that textbook is there are five states of matter. Now, they're much more than that, but really observable in the normal universe, there are four: solid, liquid, gas, and plasma. What is plasma? You just take a chunk of ice, take a good chunk of ice, and give it energy. How do you give it energy? You can heat it up in a stove. You can throw it into the middle of a thermonuclear explosion. You can focus some lasers on it. You can light a match next to it. You give it energy. And the ice melts. So it goes from solid to liquid. Molecules in a solid are fairly rigid. They do vibrate, but they don't move around too much. In liquid, they're flowing around, but sticking together. You give it more energy, and they fly away. They become gas. And think of it like a bumper carts, bumping into each other, the molecules are, but they're not really transferring energy. They're not breaking apart. If you give this gas more energy, these bumper carts start bumping into each other so hard that chunks fly off. So this is a rather high energy state, if you will. And we call that state plasma. Plasma is like a soup of various, active, reactive species. It very much depends on the gas. Like if you take the air that I'm breathing now, there is oxygen, nitrogen, there's a bit of water, humidity, even though it's winter right now. This house is still at 40% relative humidity, so it's lots of water. Also, there are pads and bathrooms, so there are some other additional gases present in pretty minute amounts. And when you start bumping those molecules into each other, they start reacting and producing very interesting compounds. Where do you see plasma? In nature, just if you go outside, you see the sun. Well, that's a big ball of plasma. Matter of fact, some believe, and I'm one of them, that more than 99% of known universe is plasma. Most glowing stars are big balls of plasma. There's a lot of plasma between the planets, so plasma is all around. On Earth, plasma is quenched by oxygen. Oxygen likes electrons, so it prevents natural formation of plasma. So you need much, much higher voltages on Earth to generate these discharges. But you see lightning in upper atmosphere. You see aurora borealis, the northern lights. And there's another really cool one. Have you guys heard of St. Elmo's fires? St. Elmo is like the saint that protects coastal cities from pirates, in a dark, dark night. And it has to be dark, and it has to be clear of clouds. A pirate ship, of course, all the lights are off. They're not flying any flag. They're trying to sneak up. So everything is really, really dark. And all of a sudden, there are these glowing lights on top of the ship, on the tips of the masts of the ship. It's pretty cool. There are corona discharges. There's high voltage between ground and upper atmosphere. And that voltage creates so-called corona discharges in the mast of ships, or St. Elmo. Anyway, so that's natural. We do make plasmas in a lab. It matters. Why do we make them in the labs? Well, nuclear fusion, that's plasma. That's a possibility for limitless, virtually free electricity for all of us. No need to rely on other sources, and these are clean plasma reactors that produce electricity. There's medicine. We use plasmas in medicine for wound healing, tissue regeneration, cancer treatment, lots of different really, really cool stuff that's being researched right now. I put up a couple of videos about that. I'll make many more, I'm sure. Engineering solutions, welding is plasma. You generate thermal plasma to melt the metal. Well, that's pretty cool. Welding is quite useful. Now there's micro welding, there's welding in space. There's all sorts of new applications being constantly developed that use these new type of plasmas. There is big move in petrochemical industry. The shirt that I'm wearing, everything's synthetic. Unless my shirts are made out of pure silk or pure cotton, they're made out of petrochemical, out of oil, reprocessed by the chemical industry. Now, what happens when we run out of oil, or when we start running out of oil, so that the price of clothing will skyrocket? So there are plasmas being developed to replace some of the applications, going from petrochemical to, for example, wood. So you can start making clothing out of wood and water and plasma and some catalyst and some more additives. The devil is in the details, so to speak, but electric discharges are being widely applied in engineering fields, in medicine, energy, and environmental applications all over the place. It's very, very cool. So next time someone asks you how many states of matter there are, confidently say at least 4. And the other hundreds of different states are mostly theoretical. If you would like to, I can talk about those, but please, subscribe to the channel, and please leave a comment what you thought of this video, whatever questions you have. I'm always happy to answer them. Thanks, guys. See you in the next one.